I'll have to go to the job site again today. Setting slope stakes is so laborious work. And I need to gather members for leveling survey. Is information and communication technology system helpful? But handling the 3D design data looks difficult.
Actually, there is an easy way to solve those difficulties.
Oh, really?
With the Excavator Machine Guidance System by National Institute of Technology Gunma College, there is no need to create 3D design model data and setting slope stakes. Believe this system is great and try to use it.
Maybe just once. Let's see if it really works.
Great. Let's do it.
In this video, we will introduce the machine guidance system following the steps you see here. We'll start with the office works first. Normally in conventional machine guidance systems, design data need to be converted to ATIN data through alignment data. For this data converting process you may need to purchase a special software and you must learn how to operate the software.
Our lab has developed a data converting software that allows to prepare necessary data for machine guidance system in a very simple manner. With this converting software, the data required for machine guidance can be created using only the numerical values readable from the conventional design data. Read alignment data, such as horizontal section, vertical section, and cross section and feed into Excel. This is what you do just as in the conventional construction process, so there is no need for any complicated work or purchase of special software.
Could it be? Next, let's perform installation of sensors and their calibration. First, 3 GNSS systems to be installed to know the current position of the machine. Next, 3 tilt sensors to be installed to know the motion of the boom, arm, and bucket of the machine. Finally, calibrate the tilt sensors attached to the machine. Measure the angles between the arm, the bucket, and the boom by a total station and compare them with the angles of the installed sensors. From the measured and calculated angles between arm, boom, and bucket, calculate deviations and enter them into initialization file. The system will automatically correct them to show corrected values.
That's all the preparation necessary. It is so easy, isn't it? And those are all the hardware items you need.
Now let's try out operating the machine guidance system.
With this machine guidance system, on a monitor installed in the cab, the relative relationship between the bucket and the design cross-section can be graphically displayed in real time. On the left side of the monitor screen, the positions of the arm and bucket on the design cross-section are synchronized each other along with the motion of the machine. On the right side, distance from the bucket cutting edge to the designed cross-section surface, offset of center position of the bucket from the center alignment, and the center line position are displayed with numerical values in real time. Therefore, the bucket position can be confirmed very precisely.
This allows operator to carry out without relying on slope stakes. These are main features of the machine guidance system developed by the National Institute of Technology Gunma College. The system is first introduced in the Tsukumo River project in fiscal year 2020. The river is located in Gunma Prefecture, which 100 kilometers away from Tokyo. The finishing result of execution with this machine guidance system passed the completion inspection in March 2020, proving its applicability to actual public works. In conventional works, a center line is defined at first, then setting stakes at intervals of 20 meters to identify the cross-section line that is set perpendicular from the center line. 4 workers were needed per cross-section line for the staking out, and in the Tsukumo River project, it was planned to take 2 days and 8 man-hours to set stakes. In addition, after the completion inspection, there is the task of removing the all stakes, which would require an additional works. With the introduction of this system, By creating machine guidance system data in Excel, we can see the current position in real time on the monitor, which eliminates the need for conventional staking out works and greatly reduces necessary manpower.
Amazingly, we were able to create the data required for machine guidance system and set up the machine only in 0.5 man-hours.
We were all very satisfied.
Why don't you use the machine guidance system developed by National Institute of Technology Gunma College to improve your productivity? We interviewed the female operator who had actually used the system in Tsukumo River project. How much experience of operating machinery do you have?
Yes, I've had my license for a little over a year.
How did you feel when you first tried to use MG system?
I didn't expect much improvement first, but it was very useful to be able to check the tilt of the bucket on the monitor.
Is it difficult to sense the current tilt angle of the bucket even for those who has good operating experiences?
Yes, it is. It's easiest to see the tilt of the bucket from the side, but when you ride in a cab, you have to look at it from the front, so I think it's difficult even for operators who are very skillful.
Do you want to use MG system from now on?
Yes, I would like to use this system from now on.
Then interviewed with the site manager. How has the setting stakeout process been improved?
Only a few stakes were needed and I could set them out by myself, and in many areas did not have to set out stakes, which makes the work very easy.
How easy was it to create the machine guidance data from the design data?
It was the same data what I usually use, so it was very easy.
How much do you think your productivity has increased?
I think it has increased 2 or 3 times.
Would you like to use it for the next job site?
Of course I would like to use it.
Thanks for watching this video. If you are interested in, please contact us at the email address in the summary section. This video was produced by Jyoshu Ladies Make Lightning and a Strong Blowing team. Please look forward to the second episode. See you.